Okay, so from our previous video, okay, so nalaman natin kung ano yung mga boundary conditions. Okay, so ano yung gagawin natin. Okay, specifically I will just re-echo or repeat what it means by boundary conditions. These are the conditions in which you apply in order that you can replace, you can compute the value of C1 and C2 respectively. Okay, so C1 is the constant you derive, after integrating d squared y over dx squared, which is equivalent to m of x over ei. So we know that kapag nag-integrate tayo is merong constant nakakabit. And then when we integrate again, okay, so when we integrate again the slope equation, so we get the deflection equation, or which is y. Okay, y is the deflection equation and dy over dx is the slope. Okay, so these are the boundary conditions. Okay, so that's it. Okay, so ngayon kaklaruhin natin. So paano ba i-solve ang slope at saka ng deflection ng beam, okay, in a practical manner. Okay, so first so ngayon isusulat ko dito sa whiteboard. So i-discuss natin ano yung mga steps, okay, on applying the double integration method. Okay, so given that you have a beam, example, dito natin siguro ilagay yung beam. Okay, so let us say ito yung beam natin. And then meron siyang mga loads dyan. It's either distributed or point loads. Okay, so it could be only one portion, okay, only one bay, or more than two. Okay, sabihin na natin continuous yan. Okay. So ano yung mga steps na kailangan nating tandaan? Okay, so first, okay, so lagay muna natin to steps. In solving beams using double integration method. Okay, so ayan. So paano natin i-solve yung beams using double integration method? Okay, specifically slope and deflections. Okay, first is solve the support reaction of beams. Yan. Ito yung unang step natin. I-solve natin ang support reaction ng beams. So, ibig sabihin, if ito yung beam natin, we need to compute the reactions. Okay, specifically, these reactions are both vertical and horizontal. And to some extent, for example, it has a interior support. So, there is a pinned, and there is moment. Okay? So let us say fixed on the other. Okay, so it a support could possibly has 1 to 3 reactions. Okay, it can have 1 reaction, 2 reactions, or 3 reactions. Okay, it could have only vertical or horizontal reaction. It can have uh, 2 reactions, which is vertical and horizontal respectively. Okay, so if you remember, so okay, so we will just review. Okay, so when we say ruler, okay, if it is a ruler, so it has 1 reaction. Okay, and then if it is pinned, it has 2 reactions. Okay, 1 reaction which is force, and then 2 reactions, force, both vertical and horizontal. Okay, so this is just a review. Okay, so and then fixed, and then for okay, so it has 3 reactions. 1 horizontal force, 1 vertical force, and then a moment. Okay. Also, this is also true for interior supports. So, interior supports also has 3 reactions, regardless if it is fixed, pinned, or ruler at the middle. So, mayroon sa 3 reaction kapag interior support siya. Okay? So, ganyan. So, ruler has 1 reactions. It is either a horizontal or vertical force, but not at the same time. Pinned, it has 2 reactions, 2 force reactions, vertical and horizontal. Then fixed, it has 3 reactions, 1 horizontal force, 1 vertical and force, and 1 moment. And then interior supports, regardless of your whatever it is, it has 3 reactions. Okay, so also there is also an exemption. Okay, so kapag interior supports na ruler or pin, okay, so we are talking about ruler, pin, or fixed. So there is also an exemption here. Okay, so there are times that there is an interior hinge. Okay, so if it is stated in the problem that it is an interior hinge, so therefore it has only 2 reactions. But otherwise, if it is an interior supports, ruler, pinned, or fixed, it has 3 reactions. So that is how it is. Okay. So the next step is i-apply natin. Okay, apply boundary conditions. So it is already explained in the second video. Okay, what is the boundary conditions? Okay, we apply boundary conditions to solve constants. Okay, C1 and C2. Okay, so the main purpose of applying boundary conditions is to solve the constants, which are C1 and C2. And then the third, we already solved the supports and the reactions of beams is, okay, construct the moment equation. So this is the third. So this is the third step. Construct the moment equation. So these are the steps. Solve the support reactions of beams, apply the boundary conditions, and then construct the moment equation. Okay? So, what is the next? After constructing a moment equation, Okay? This is in the form of m of x. Okay, so we are talking about m of x. Okay? So, maybe we will discuss how to construct a moment equation in another video. Okay? So, after you compute the moment equation, you apply. Okay? So, you apply this one. Okay? So, there are two ways in which we can compute. Okay? So, construct the moment equation. Then, afterwards, okay? So, determine the slope equation. Okay, so other books represent it, okay, this way. Okay, so other equations is, okay, other is, we represent it this way, okay. Okay, okay, sorry. So, it should be represented this way. Okay, so, m of x ei dx. Okay? So, that is plus c. Okay. So, you can compute the c, okay, using the boundary. I see one using the boundary conditions. Okay, so in another books, you can also use this one. Instead of using this equation, you can use also this equation. Okay, pwede nyo ito magamit ang equation na to. Okay. So, kaya lang, the C1 here and the C1 here, okay, is not equal. So, they are not equal. Okay? So, if you are using C1, using this formula, you will get a dimensionless value. So, this is dimensionless in this equation. And this is not dimensionless. It has a in terms of kilonewton meter squared in SI. And then, it could be libra foot squared, and then the similar ways, okay? So, ang C1 dito at ang C1 dito na equation at ang C1 dito is magkaiba. So, whatever formula you are using, whether this or this, magkaiba yung C1 nila, but in the end, they should end up with the same answer, with the same deflection at any given point, okay? At any given value of x, okay? At any given value of x, whether you are using this or you are using this formula, you will get the same value for the slope and also for the deflection, okay? So, whether you use this or this, it is acceptable, okay? Also, you can determine the deflection equation. And again, you should not be confused, okay? Whether you are using this or you are using this, it is applicable, okay? Same answer for any value of x. So, y or your deflection is equivalent to m of x, okay? Double integral of m of x ei dx dx. So, why there is double x? Oh, dinoble yung dx natin kasi after ma-integrate, mawala itong dx. Kung integrate natin na agad, ulit, mawala na talaga yung integral. And then, c1x plus c2. Okay? So, you may use this or other books may use this one. EI, Y, okay? Also, this one, dy over dx is equivalent to y bar. This, okay? It would be also this one, oh. M of x, okay? Double integral dx dx plus c1x plus c2, okay? Please take note that the c1 and the c2 here is different, of different values, okay? So, this C1 here is also is in terms of unit, mm or inches or whatever. Here is in kilonewton, okay? Kilonewton meter cube, libra foot cube, etc. Okay, so uh they will not be the same, okay? The C1 and C2 here respectively in this equation and this equation are different, okay? So maybe we will understand these steps in solving beams using double integration method as we going to have um, some examples in the next videos. Okay, so lagi niyong tandaan itong 5 steps in solving beams using double integration method. Okay, solve the support reaction of beams, apply boundary conditions to solve constant C1 and C2, construct the moment equation. Pag nakuha mo na yung moment equation, i-apply mo dito. It's either dito or dito, pili ka. Kung ito na yung ginamit mo, ito yung gamitin mo, okay? Partner sila. Kung ito yung ginamit mo, then ito din yung gamitin mo na equation. So, in order to determine the slope equation and the deflection equation. And after that, kung if it is asked what is a deflection at distance x equals something from the left support, you can already solve if you have determined the slope equation and the deflection equation respectively. Okay, so maybe in the next videos we'll have example, and then in the fourth part of this series we will discuss how to this third step, how to construct the moment equation. Okay, so please watch the next set of videos.